Alright, so today we're going to be graphing square root and cube root functions. So we're going to start with problem number 1, and it is a square root function. So we're going to draw it on our graph. So you go to y equals and you type in square root of x minus 3. Alright, so I'm going to hit graph. Oops. And if you get a graph that doesn't fit on your, or you're not in the standard window, hit zoom 6 and now you'll be looking at your standard window. So it looks like a half of a parabola. If you look at what we have here, I need to find my starting point. It's not exactly called my vertex, but I look at the opposite of this number and exactly the number that's on the outside. So that tells me that my starting point should be at 3, 0, because there's really like a plus 0 there. Okay, and if you look at the graph over here, it looks like it starts at 3, 0, and it goes up. So if the value that's in front of the radical, if that's positive, then it would go up. If it's negative, it would go downward. All right, the other thing we're going to do is we're going to make a table of values, and you're going to try to write down, so hit second trace. You try to write down as many of the integer locations that you can. So notice that a bunch of these say error, and the first one that starts is that starting point, right? 3, 0. We've got 4, 1. And we're going to skip over that one. We're going to just write down 7, 2. And that's all that's going to fit. We can write down 12, 3, but that doesn't quite fit on our graph. All right, so you plot your points, 3, 0, 4, 1, 7, 2, and we can do 12, 3. It's over here. So this replicates what we saw on our graphing calculator earlier. Then it asks you, what is the domain? So you need to set the radicand. Remember, the radicand is the part that's underneath the radical. You can't take the square root of a negative number, so that value, x minus 3, has to at least be 0 or greater. So we're going to solve. If we add 3 to both sides, you get x is greater than or equal to 3. So that is your domain. All right, so x can be any number 3 or higher. One way you can also see that on your calculator is to look at your table. And notice that the first value that you actually get a y answer for is 3. Anything earlier, you get an error. So this tells me that it can only start at 3 and go higher. So either look at your calculator or you can just set up the inequality and solve it to find your domain. All right, so this is also a square root. So you look at the number that's the opposite in here and exactly the number that's outside. So that tells me I'm going to start at 0, 2. So I'm going to make my table of values. If I've got the square root of x, make sure that you close the parentheses, or if you have the new calculator, you hit the right arrow to get out of the radical, and then add 2. So we know we're going to start at 0, 2, and that's what it looks like over here. So to hit second graph, you can look at your table. Notice we have an error, and then I'm just going to write down all the whole number values that I see. And 9, 5 is the last one that's going to fit. Alright, so I'm going to look at 0, 2, 1, 3, 4, 4, and 9, 5. So I have a half of a parabola that goes upwards because this number is a 1, which is positive. And if you look at the value that's underneath the radical, that's our radicand, just say that that has to be greater than or equal to 0. And notice I don't need to solve in this case, so that's my final answer for my domain. All right, so we're going to keep going with 4 more examples. All right, number 3 is slightly different. So notice that it is a cube root function. All right, it's not going to be a parabola. It's going to be like an S shape. So if you need to pause the video, you can go ahead and write these down. But essentially, you start the same way. You look at what's the opposite of this, and exactly this number. So my starting point is going to be 2, 0. So if I go here, I'm going to do the cube root of x minus 2. And I'm going to look at my table. All right, so we have 2, 0. We have 3, 1. But we also have numbers before that. We've got -1, -1. I'm going to get one more point. We have -6, -2. And then I've got another point in this direction as well. 10, 2. So unlike in the square root problems, we didn't have any errors in our y column. So that's another reminder that this is going to go on forever in both directions. So -6, -2, -1, -1, 2, 0, 3, 1, it might have been positive 1, 1. Positive 1, negative 1. Not that point. All right, this is at 3, 1, and 10, comma 2. So you get this half parabola going this way and another half parabola going this way. All right, and notice that this graph goes on forever, so the domain is all real numbers. Remember, domain is what are the values of x that are valid in this problem. And all of them are valid, because you could take the cube root of negative. So there's no restriction, unlike when we had square roots, there was a restriction. Okay, back to square roots for the rest of the problems. So look at the opposite of this number, right? It says 2x, but there's no number being added or subtracted, so it's 0, comma 0. All right, and if you look at your table of values, so we're going to do square root of 2x, and go to my table. Right, you're going to see there's an error, so the first value you're going to start with is 0, 0. And then we got 2, 2, and there might be maybe one more that you can plot. 8, comma 4. So we got 0, 0, 2, 2, and 8, 4. Alright, so we've got our half of a parabola opening upwards. And our domain is that 2x has to be greater than or equal to 0. So that's my radicand. Notice I didn't have to do that in this problem because it was a cube root. You only have to do that for square roots. So to solve for x, I get x has to be greater than or equal to 0. Also notice that it's always been our x coordinate of our starting point. Right? This was 3, so my domain was greater than 3. Here this was 0, so my domain was greater than 0. This is 0, so my domain is greater than 0. Alright, so I'm going to look at my opposite of the number that's next to the x, exactly this. That tells me to start at 0, negative 2. So if I go to graph, and go to y equals negative 3 times the square root of x. Now I need to close my parentheses and then do minus 2. Alright, so in my table, I'm going to start at 0, negative 2. I have 1, negative 5, 4, negative 8, and possibly one more that we can write. We could do 9, negative 11. Alright, so plot all those points. 0, negative 2, 1, negative 5, 4, negative 8, and 9, negative 11. Notice this one is a half of a parabola that opens downward. The reason for that, this tells you that you have a downward facing parabola, or downward trending parabola. Alright, so our domain is what's the value under the radical, x, and it has to be greater than or equal to 0. So nothing needs to be solved for. That's your final answer for your domain. And again, that's your starting x value. Alright, last problem. Take the opposite of this and exactly this. There's nothing here, so it's 5, comma 0. And I've got 5, 0. So if you go to y equals, we got 1/3 times the square root of x minus 5. And your graph is going to look like this. It's kind of skinny, right? It's barely there, right? So we start at 5, 0. And if you look at your table of values, there's really no other decimals or there's no other whole numbers to plot. So we'll just go with like a nice decimal. 6, comma 0.3 repeating, and then 9, comma 0.6 repeating. That one's easy to write down. So 6, we're at 0.3, and at 9, we're at 0.6. So barely above the 0. So that's why it's really small looking compared to our other graphs. Domain is x minus 5 has to be greater than or equal to 0. That comes from this radicand. Right? And to get x by itself, I add 5 to both sides. So that tells me x has to be greater than or equal to 5. And as always, it's our x coordinate. That's the number that has to start at and go on from there. So x is greater than or equal to 5.